Good afternoon, students. Today we are going to discuss Module 5, Phase Locked Loop, that is PLL. So let us go the introduction of this phase locked loop. Basically, the phase locked loop is a closed loop system. Here, the application of this PLL is to lock the output frequency with the phase of the input frequency. And coming to the application of PLL, it is generally used in multimedia and communication systems and so on. And here, basically, there are two types of PLL. One is linear PLL, another one is non-linear PLL. This non-linear PLL is very difficult and it is complicated to design in the real world. So we use the linear control theory, that is in analog PLLs. So this linear PLL has proved that the linear model is sufficient for most of the electronic application. Now let us move on to the topic, basic block diagram of your phase locked loop. This is the basic block diagram of your phase locked loop. And here we are having three important components, okay, of PLL. What are the three important components of PLL is phase detector, low pass filter and voltage control oscillator. These are the three important components of your PLL. So here the input signal having some frequency that is given to the phase detector, and the output of the VCO will be taken and it is given to the phase detector. Okay, so in this phase detector, the input frequency and output frequency will be keep on tracing, that is keep on comparing. So the phase detector will be act as a comparator. Here this phase detector will be act as a comparator. The input signal VA is having frequency F1 and the output frequency that is the output of the voltage control oscillator will be taken and it is given to the phase detector. Now the frequency of this input signal will be compared with the phase of your output signal. Okay, the frequency of the input signal will be compared with the phase of your output frequency. So here the phase locked loop, as I said earlier, consists of three important components. One is phase detector, VCO and low pass filter. So here the phase detector will compare the input frequency and output frequency, so that it is called as a comparator. The phase detector is also called as a comparator. The output of the phase detector is nothing but addition of these two things, that is Fi input frequency and F0, that is output frequency, which is a DC voltage. The output of the phase detector is DC voltage, and this output of the phase detector will be given to the low pass filter. Here the output of the phase detector will be given to the low pass filter. This low pass filter, you know the characteristics of the low pass filter. After the cutoff frequency, the filter will not allow to pass any frequency. So this low pass filter will eliminate all the high frequencies, and produces only the steady state DC level. That is nothing but Fi minus F0, that is the input frequency minus the output frequency. The low pass filter will remove all the high frequency and it will produce only the low frequency signal, and this low frequency signal will be given to the your voltage control oscillator. So this is about your basic block diagram of PLL. PLL is nothing but just it will take the input and the output will be compared with the input. So that is the output frequency will be compared with, the input frequency will be compared with the output frequency. Now again, the output of the low pass filter, I already said that the output of the low pass filter will be DC level and it is passed to the VCO. So the output of this voltage control oscillator is F0, and this output will be compared with your input frequency. The input and output frequencies are compared and adjusted through the feedback loop. Already I have said that the output of this low pass filter is DC level, and this DC output will be given to the VCO. You know that output of the VCO is F naught. Here this F naught will be compared with your Fi until both the frequency will get the lock. Both the frequency should be same. Until that it will keep on, it will track. So here this PLL is works in three conditions, that is free running, capture and lock range. What is meant by free running means under this free running stage there is no input to the PLL. So that we can call it as a free running stage. And what is meant by capture range means when the input is given to this PLL, the VCO starts changing the output, and that the produced output will be compared with your input frequency. That is called capture range. Now next, I already said the components of your components of the PLL. Components of PLL is nothing but we are having three important components: phase comparator or phase detector, then voltage control oscillator, loop filter. I also told all these three functions of this components of PLL. So comparator is nothing but it will compare the input frequency and the output frequency, and this comparator will generate the DC output. And this DC output will be given to the next loop filter. This is DC output will be given to the low pass filter, and that low pass filter output is also DC, that is given to the voltage control oscillator. And this voltage control oscillator it will generate the radio frequency signal that is considered as the output of the loop, and its frequency can be controlled over the operational frequency band which is required for the loop. So the frequency which is generated by the VCO will be in the range of radio frequency. So this is very important. The frequency of this VCO will be in the range of radio frequency, and that frequency will be required for the loop. And this loop filter is also very important in the PLL, and this loop filter is will be taken from the output of this VCO will be taken, and it is given to the this one phase detector. The filter is used to filter the output from the phase comparator in the phase lock loop. It is used to remove any components of the signals which the phase is being compared from the VCO line. This is also very important. So this will have many characteristics. The characteristics of the loop filter is nothing but your stability and speed of lock. All those things will be contained. Okay, thank you, students.